Hi, and welcome to Learning Scala Web Development video course by Pact Publishing. Before we start, just a few words about me. I'm Andrew Redco. I am an experienced software developer with a great passion to technology and software engineering in general. Over the years, I have been working professionally with many programming languages and platforms. However, once I discovered Java approximately 8 years ago, I fell in love with its ecosystem and community. The movement to functional programming paradigm had captured my attention a few years ago when I discovered Scala programming languages. Functional style and Scala in particular captivated me immediately by its power and conciseness. I also post quite regularly about different technical topics on my own blog. You can always find and contact me there. In this video, we're going to take a general overview of the course and glance through technologies and frameworks we will be using along the course. In this course, we will learn the foundations of the web development using Scala programming language and ecosystem. As web development in general is a huge topic, we will be focusing on developing RESTful web services and APIs only, picking the best of class frameworks available at the moment. Although the course is pretty straightforward, there are quite a few topics to be covered. First and foremost, we are going to get a tour around REST architecture style, its principles and constraints. From that, we will move on to an overview of Actor Model. Although REST architecture and Actor Model are not related, it is a very important piece of knowledge we will need later on. With that, we will conclude the theoretical part of the course. On a practical side, we're going to progressively build our first RESTful web services and APIs. Once we cover server-side, we will finish up by developing a few clients to show off the best practices of consuming RESTful web services, including the ones we have just built. This course requires a very basic knowledge of Scala programming language. Nonetheless, Scala is a very feature-rich language. We will try to stick to simple constructs whenever possible. There are 3 mainstream integrated development environments, or just IDEs, which most of the Scala developers use these days: Eclipse, NetBeans, and IntelliJ IDEA. In this course, Eclipse for Java Developers Edition with Scala IDE plugin installed is going to be development environment of our choice, but do not worry if you are using IntelliJ IDEA or NetBeans. All the projects we will develop are going to be IDE independent and easily importable to any of those, thanks to using SBT or Simple Build tool. Along the course, we will have enough information available at our disposal all the time. However, it is a good idea to visit Akka or Spray websites to get more details about the topics left behind, or read about latest news and releases. In this video, we have had a general overview of the goals of this course, along with touching the key technologies and concepts we will learn about. Hi, and welcome to Section 1. This section is going to be the starting point of our journey into the world of RESTful web services. In this section, we will grasp the basics of what REST architecture style means in the context of HTTP web services. Once we answer this question, we're going to make an overview of the state-of-the-art technologies of RESTful web services development on the JVM platform. And welcome to the second video of this section, and get a brief idea of what REST architecture is all about. It should be enough to build a solid understanding of the foundations that RESTful web services are based on. In this video, we'll touch on what REST actually is, and move on to get an overview of how it came into existence. We will then move on to view the essential REST principles, and spend some time focusing on REST value proposition and its constraints, along with discussing when to use REST. REST, or representational state transfer, is a style, a different way of thinking about architecture and designing web applications, services and APIs. For our industry, REST could be considered an old thing, as its roots are dated back to 2000. From the beginning, REST was designed to be independent from the underlying protocol, but nowadays, Thanks to tremendous popularity of the Internet and World Wide Web, it is most widely used in the context of HTTP web services and APIs, heavily relying on semantics of this communication protocol. The REST style has many appealing properties and principles that address the challenges which modern web applications and services are facing today. Among many, there are a few worth distinguishing. The uniform interface simplifies data manipulation. A client-server model separates clients from servers. Being stateless assumes no client context is stored on the server between requests, although in reality, servers may need to access some state associated with the client, also known as session state. Caching helps to eliminate unnecessary round trips between client and server. Layered system design is the enabler for altering client-server communication without changing any of them. We will now take a look at each of these principles in detail and discuss the importance and benefits of every principle in the context of HTTP-based distributed system communications, spread across processes and physical machine boundaries. Uniform interface. Individual resources are identified using URIs, or, as we get used to it in the context of the web, URLs, which are a subset of URIs. They are sent to clients using different representations, notably JSON and XML. The client can manipulate the resources through the representations and submit them back to the server, using appropriate HTTP verbs like post, put, get, delete, patch, head, and options. Client-server separation. The clients and servers are naturally separated from each other, giving each part the freedom to evolve independently. The most popular example of these clients these days are web browsers, literally installed on every single device out there. Although we as users deal with full-fledged websites most of the time, web browsers can access RESTful web services either directly, using add-ons, or through JavaScript code execution. In the current era of mobile boom, RESTful web services play a key role in mobile application architectures, as mostly any application installed on our mobile phone is powered by some sort of RESTful web service or API. Stateless. The server does not store any client context between the requests. Each request from any client contains all the information necessary to serve the request using headers, query, and path parameters or body. The session state is always held on the client. Cacheable. Responses from servers could be cached by clients, although responses must describe themselves as cacheable or not. Caching, when done right, may significantly improve scalability and performance, as the next time the client needs to execute the same request, the communication with the server could be completely avoided. Note, it is faster for the client perspective. It also removes unnecessary load from servers. Layered. Clients cannot tell for sure whether they are connected to the server directly or through an intermediary. This gives us the opportunity to improve overall system scalability and safety by introducing load balancers, API gateways, shared caches, and security policy enforcements. There is often confusion around REST web services and RESTful web services. However, it is very easy to draw a line between them. RESTful web services conform to all the required principles and constraints of the REST architecture, while REST web services follow some, but not all. Taking into account REST principles we have seen before, it becomes apparent that they are quite simple but powerful. Simplicity is one of the core values of REST. But simplicity does not come alone and brings the agility with itself. RESTful web services encourage rapid development cycles and require much less time to production. Not only that, because of those loose coupling between servers and clients, RESTful web services can evolve very fast as well. It's very important in the era of modern highly competitive markets. In this video, we have been introduced to REST architecture style and the concepts of RESTful web services. In a nutshell, REST architecture was a breakthrough in the area of web services and web APIs, but building loosely coupled distributed systems without following strict contracts is a real challenge. In the next video, we're going to take a closer look at the unique technologies of the RESTful web services development on the JVM platform. Hi, and welcome to the third and last video of this section. Here, we're going to take a look at the state of RESTful web services development on the JVM platform and get a brief idea of the three key trends that drive the RESTful web services development in the Java ecosystem. We start off by taking an overview of the existing and upcoming Java specification requests, or JSRs, for the Java Enterprise Edition platform. Then, we will escape from the Java universe, though only for a moment, and look at how other programming languages and frameworks inspired the RESTful web services development on JVM. Lastly, we will discuss how the latest movement to asynchronous and non-blocking programming models has affected the landscape of RESTful web services and API development, bringing even more options to the table. The official Java process is known to be quite slow with respect to changes in the platform and reacting to the latest industry trends. This explains why the 1.0 specification of Java API for RESTful web services, or simply JAX-RS, has been adopted only in 2008. Since then, the process has sped up, with the next major version, 2.0, being released in 2012. The upcoming version 2.1 of the specification is a work in progress right now. The JAX-RS space is somewhat crowdy, with at least 4 major players at the moment: Jersey, REST-easy, RESTlet, and Apache CXF. Mostly all of them implement JAX-RS 2.0 specification, but also introduce their own features and, in most cases, non-portable extensions. The Java ecosystem does not evolve in isolation, which is a very good thing. We as a community learn a lot from the successes or failures of other programming languages and frameworks. A couple of the most notable examples are Ruby on Rails and Django, since they inspired 2 very popular full-fledged web application frameworks, Grails and Play. It's worth mentioning that although Grails and Play are often used to develop websites and applications, they both provide excellent foundations for building RESTful web services and APIs as well. Traditionally, HTTP web requests from clients were handled on a one thread per request model. In essence, this means that for each client that invokes a RESTful web service or API endpoint, the server allocates a new thread that will serve the request up to the point when the response is sent back to the client. It is a simple model, which has worked quite well in the past. However, this model has proven to be ineffective in addressing the scalability requirements of modern web services and APIs. With thousands of requests hitting the server each minute or second, the one thread per request model led to quick exhaustion of the available resources. At this point, the search for scalable and efficient models turned the industry's attention towards asynchronous and non-blocking paradigms, which, to some extent, have affected the ways in which we build RESTful web services and APIs. We will see all these concepts in action while building our very first RESTful web service. Let us take a look at the implementation based on event-driven loops and worker thread pools, which is a norm these days. Conceptually, threads are still there, but the way they are being used is very different. The request and response processing are not tied to the same thread anymore. The niche of RESTful web services development on the JVM platform has really flourished in the recent years. There are many micro and macro frameworks available out there, each one with its own pros and cons, so the choices are literally endless. However, there are quite a few that are built with an emphasis on asynchronous and non-blocking programming models. They are being actively developed, have large communities, and are being used in production. Ratpack, Spring MVC, VertX, and Spray, which is going to become a part of Akka project, namely Akka HTTP. Each of these frameworks is worthy of its own course. But in this one, we're going to focus on the Spray framework to be our foundation for building scalable, reliable, and powerful RESTful web services and APIs using Scala. In this section, we got familiarized with REST architecture style and looked at the state of RESTful web services development on the JVM platform. We also brushed up on specifications and discussed a few modern programming models and frameworks. In the next section, we're going to switch our attention from RESTful web service development towards Actor model concepts, and we'll focus on the Akka framework for the reference implementation. Hi, and welcome to the second section of this course. In the previous section, we have had a brief introduction into the REST architecture style and state of the RESTful web service development on the JVM platform. In this section, we will get acquainted with the Actor Model and Akka framework. Although both of these are not strictly related to RESTful web services and APIs development, this knowledge will help us a lot to understand the Spray framework design and implementation. In this section, we will briefly take a look at the concurrency and parallelism as the foundation to build high-throughput web applications. We are going to see the pros and cons of traditional mutable shared data approach versus share nothing design by exploring Actor Model and Akka framework. It is worth to mention that Actor Model is not the only alteration available, with different forms of non-blocking programming models being the best example. Now, we will move on to the first video of this section, where we're going to discuss the traditional ways of concurrent and parallel programming. In this video, we're going to discuss how the hardware evolution affected the software evolution. Threads, shared mutable state, and synchronization became well-known concepts for every software developer, particularly on the JVM platform. However, very quickly, we as the industry realized that writing scalable software systems which employ concurrency and parallelism in a right way is really, really hard. The chase for keeping up with Moore's law forced processor manufacturers to shift their focus from delivering increased CPU clock rates to multi-core CPU designs. In turn, such a shift in hardware design led to a deep rethinking of the ways software should be built, in order to leverage this new additional computing power. More and more applications, especially the web ones, embraced concurrency and parallelism, effectively moving away from single-threaded to multi-threaded execution flows. The future looked bright, at least in theory. Leveraging more cores should lead to linear increase in performance and throughput as more computations could be done in parallel. In reality, though, it turned out that things do not work out well all the time. At least on JVM platform, concurrency and parallelism based on multi-threading model introduces overhead, often very significant. In most cases, the culprit is mutable shared state, as multiple threads are not working in isolation, but have to communicate and exchange data with each other. Not to mention expensive context switches and cached lines in validation. If data is shared using read-only access patterns, it does not cause any problems. However, when multiple threads are trying to modify the same data structure simultaneously, it becomes a real issue. Also known as a race condition. The consequences may vary, ranging from very hard to reproduce bugs to catastrophic data loss and corruption. Synchronization is the key player in coordinating the access to shared mutable state during race conditions. In the essence, usage of different synchronization primitives, like, for example, locks, monitors, mutexes, semaphores, ensures that the read and write operations are properly ordered, and one and only one thread is able to modify the shared state at any time. Surely, there is no such thing as a free lunch, and synchronization is not free either. It causes another class of collisions, known as lock contention, thread starvation, and deadlocks. Plus, overusing synchronization primitives leads to dramatic performance degradation, basically nullifying the benefits of additional computing resources. At this moment, it becomes apparent that it is really a tough task to properly use concurrency and parallelism based on threads and shared mutable state. Using too many threads is going to slow down the application because of large amounts of context switches required. From other side, not enough threads may not considerably boost application performance and underutilize the available hardware resources. Presence of mutable shared state and mandatory use of synchronization to guard it has a lot of pitfalls, like lock contention, thread starvation, and deadlocks. Probably the most important side of concurrency models based on multi-threading is non-determinism. As such, it is very difficult to reproduce the issues and, as a direct result of that, to find and fix the cause of them. In this video, we have looked at how the shift to multi-core processor design changed the way we used to develop software. Certain level of concurrency and parallelism is the integral part of most of the modern applications, particularly web ones. We also discussed the traditional ways of achieving concurrency by using multiple threads, and how difficult it is to coordinate the access to mutable shared state in such an environment. In the next video, we're going to delve into another concurrency and parallelism model based on message passing and actors, which is known as Actor Model. Hi, and welcome to the second video of this section. In the previous video, we looked at concurrency and parallelism models based on threads and shared mutable state. In this video, we're going to take a look at some high-level concepts of the Actor model and message passing concurrency. In this video, we're going to take a look at how the simple concept of actors and messages could be used to harness the concurrency and parallelism in a wide range of applications and services. As we are going to see, there are pros and cons of using the Actor model. However, for many kinds of software systems, it works perfectly well. As most of the modern mainstream software development models and paradigms, Actor model was created and formulated a couple of decades ago, in the early 70s. One of its first successful implementation was done by Ericsson as part of the Erlang programming language. This language is still there. Moreover, it is worth to note that these days Erlang is gaining a lot of traction, particularly in telecommunication industry, proving many times that the Actor model really works in practice. Just to mention WhatsApp, Ryak, and RabbitMQ as best examples. In the essence, Actor model revolves around actors, behavior, and messages. The actor is some kind of entity or concept which fulfills a very few simple rules. It encapsulates the behavior to react to the messages sent to him by other actors. It also can send messages, create new actors, and change its behavior with respect to processing next messages. Although it might be not obvious at first glance, but Actor models is inherently concurrent and asynchronous. Actors do not share anything with each other and communicate only by sending messages, which, by the way, are also immutable. If some subset of actors needs to share common state, it is all done by including it as part of the message payload. Under the hood, Actor's intrinsic design is quite simple. Every actor has a mailbox, also known as message buffer or queue, where messages are kept while waiting to be picked up. Another part of the actor is message loop or message handler, where the messages are being properly processed. The extremely important implementation detail is that the actor handles only one message at a time, in a single thread. Because of that, actors may have their own initial state, which could be accessed without any synchronization required, as no race conditions are possible. For sure, if actor follows the rules and does not violate them by creating own thread pools and whatnot. This model encourages sticking to much simpler development decisions, as there is no need to worry about threads, synchronization, and mutable shared state. The actor model is a great example of messaging passing concurrency. The work is split between many participants, or actors, which communicate by means of passing messages to each other asynchronously. In most cases, messages are one way. However, the sender, actor, may wait for reply message from the receiver, another actor, if necessary. If there is too much work, additional actors could be created at any time. Most importantly, actors may cross the boundaries of JVMs and physical machines, preserving the transparency of the communication and embracing elastic scalability. Obviously, looking back at what we have discussed so far, it is quite clear that the actor model has a lot to offer. Simplicity and absence of shared mutable state are just a few strong points to mention here. However, the valid question to ask is, why isn't it so widely used today? Fair enough, there are many reasons which kind of restrain the actor model adoption. First, asynchronous messaging is not for everyone. It forces to rely on different development paradigms and practices, which many people find to be hard to understand. Secondly, the problem being solved should be decomposable, so it could be split between many workers, actors. And lastly, troubleshooting the issues in such a very loosely coupled system is not easy, as there could be millions of actors and messages flying around. In this video, we have briefly looked at the actor model and message passing concurrency. It represents the alternative approach to concurrency and parallelism, which is more often than not based on threads and mutable shared state. We have had a chance to compare those two approaches and understand the pros and cons of each other. There are much more to say about actor model, but the knowledge we have gained at this video is enough for us to move forward. In the next video, we will explore one of the popular actor model's implementations, namely Akka Framework, also known as Akka Toolkit, written completely in Scala programming language. Hello, and welcome to the third video of this section. In the previous video, we looked at the history and theoretical concept of the actor model. Now, it is time to switch from theory to practice and get familiarized with one of the examples of the real-world implementation. In this video, we're going to take a look at Akka Framework, or Toolkit, one of the popular implementations of the actor model, written completely in Scala. We're going to start off from the brief history of Akka, so as to get the idea of how mature it is. From that, we will move on and take a look at what are the actor systems and their role in bringing the actors to life. This is the first place in the course where we're going to see a few code snippets. To be fair, the list of Akka features is quite long, so we'll try to keep our focus on the things we really have to be aware of. As we remember from the first video of this section, Erlang programming language was one of the first successful implementations of the actor model. It comes with no surprise that Erlang was, and still is, an inspiration for many implementations of the actor model, and Akka is not an exception in regard to this. Before Akka came into the picture, Scala programming language, more precisely its standard library, had own implementation of the actor model. However, since its birth in 2009, Akka very quickly gained the popularity and became the de facto actor model implementation in Scala ecosystem, and arguably on JVM platform in general. Akka evolves and hopefully is going to evolve at great pace. Although it is started as Actor Model implementation, the Akka we know these days is much more than that, being a really useful toolkit for building a wide range of distributed software systems. Still, the actors are at the heart of Akka, and we're going to focus on this part only. In practice, managing actors and providing certain level of messaging delivery guarantees are tough problems to solve. Akka tries to hide as much complexity as possible behind useful abstractions. One of those abstractions is an actor system which manages the resources and facilities required in order to run the actors, for example, scheduling services, configuration, logging, etc. It is good to know that several actor systems may coexist within the same JVM process, as there is no global shared state between them. The transparent communication between actors and actor systems still remains true. The actors could send messages to other actors within the same actor system, or to the actors in another actor system, which could coexist within the same JVM, some physical node, or be distributed across the network. Now, let us move on and have a sneak peek on how simple it is to define a new actor using Akka. Basically, all we have to do is to create a new Scala class. Let's name it Sample Actor, which has to extend the actor class from the Akka framework. In this class, we have to define a receive method, which is going to serve as a message loop. It is a typical partial function, quite similar to Scala developers, so it could be implemented using pattern matching expressions. Once the actor is defined, it could be instantiated, which makes it available for receiving messaging and doing all the things it was designed to do. This is a responsibility of actor system, which should be instantiated first, usually with some name assigned to it. Instance of the actor system, among many other things, allows in turn to create actor instances by invoking actor of function. It accepts the actor configuration in a form of props, object, and optionally, desired actor name. This name could be used later by finding the actor reference in the actor system. Interestingly enough, if you expect the result of the actor of invocation to be the instance of the sample actor class, you're going to be surprised. In fact, actor of returns the actor reference instead. From this point, the actor is instantiated and ready to be used, but we're going to stop here. But don't worry, we will see the actors in action right in the next sections while building our RESTful web services with Spray framework. Akka is a key foundational building block of many very popular libraries and frameworks. Among those are Apache Spark, Apache Flink, Scalatra, Gatling, and of course, Spray framework, which we are going to learn along this course. All of them are being used in production every day, gaining more and more adopters and proving Akka's readiness to address real-world challenges. In this section, we have observed different concurrency and parallelism models, learned about Actor Model and Akka framework, its Scala-based implementation. Although we have not touched many interesting topics like fault tolerance and supervision strategies, actors hierarchies, clustering, and many more. We have gotten enough knowledge to move to the primary topic of this course, building RESTful web services using Spray framework. In the next section, we are finally starting to learn Spray framework. Be ready to roll up those sleeves, as there are a lot of really cool coding exercises ahead of us. Hi, and welcome to section 3 of the course, Building RESTful Web Services with Spray. In this section, we're going to actually start building a real RESTful web services using Spray framework, applying in practice all the knowledge we have acquired in the previous sections. We will gain understanding of the Spray framework by discussing its modular structure, philosophy, and design principles. Right after that, we'll get a close look on two core modules which play a key role in RESTful web services and APIs development on top of Spray Framework: Spray Routing and spray-json. Armed with this knowledge, we can start coding the skeleton of our book catalog, RESTful Web Services. And what could be a better end of the section than consuming our freshly developed RESTful web services? We will gain insights on how to use browsers or command line tools as clients for the HTTP-based RESTful web APIs. Now we are moving on to the first video of this section, where we are going to feel the magic of Spray Framework, learn its philosophy, foundations, and design principles. At the very last, we are going to spend some time talking about Spray versioning policy. It is going to help us to pick the right set of dependencies, like Akka, for our projects. In this video, we're going to take a look at Spray Framework in general, starting from its proper definition and brief history. Understanding the design principles is very important to master any framework or library, and is applicable to Spray as well. We will spend some time discussing the decisions which influence Spray's design, concluding how Scala and Akka provided the necessary foundation to implement them. Close to the end of this video, we're going to discuss how Spray's modular structure reflects its philosophy and provides the necessary building blocks at every layer of HTTP-based communication. The very important topic of compatibility between Spray, Akka, and Scala is going to be addressed as well. So far, we've always referred to Spray as a framework, taking into account quite blurry definition of what framework actually is. In fact, Spray positions itself more like a suite of libraries than a framework. For many of us, there's not much difference. However, there really is. And for simplicity, we're going to continue to refer to Spray as a framework, or just Spray. Akka and Spray are somewhat age mates. The first official release of the Spray became available in 2011. Spray design is heavily influenced by a set of core simple principles, which makes this framework a compelling choice for building RESTful web services and APIs. All APIs built on top of Spray are fully asynchronous. Blocking code is avoided whenever at all possible. Spray fully embraces the actor model and heavily relies on Akka for that. Most, if not all, Spray components are carefully crafted for excellent performance in high-load environments. All Spray dependencies are very carefully managed to reduce the footprint. Spray is structured as a set of integrated but loosely coupled components. Every application only depends on the parts it actually needs. Spray components are structured to be easily testable. We already discussed that in one way or another, but it's worth repeating that Spray foundations are Scala programming language along with its library and Akka framework, which in turn is also written solely in Scala. Without such solid foundation, Spray framework probably would have never been created. Understanding the purpose and functionality of each Spray module is very important, as it allows us to pick up the ones we really need. Spray.io provides a low-level network input-output layer for directly connecting Akka actors to asynchronous Java NIO sockets. Spray HTTP provides an immutable model for HTTP requests, responses, and common headers. Spray HTTPX provides higher-level tools for working with HTTP messages. spray-json provides a low-level, low-overhead, high-performance HTTP server and client built on top of Spray.io. Spray Routing provides a high-level routing domain-specific language, or simply DSL, for elegantly defining RESTful web services. Spray Servlet serves as an adapter layer, providing the capabilities to integrate with Java Servlet API. Spray Client provides higher-level client-side HTTP support. Spray Caching provides fast and lightweight in-memory caching. spray-json provides a lightweight, clean and simple JSON implementation in Scala. Spray Util is a small utility module used by all other modules. Spray Test Kit provides a DSL for easily testing Spray routing services. In this video and along the previous two sections, we have talked a lot about Scala, Akka and Spray. However, we have never brought up the realities of building any kind of applications using Scala programming language and ecosystem of its libraries. To put it in context, as Scala programming language evolves, new features are added to the language, along with old ones being deprecated or removed. There are many versions of Scala available in the wild, but the most recent ones are 2.10 and 2.11.6. Every application, framework, or library, including Spray and Scala, are developed and released against one or several versions of Scala. Along this course, we're going to use the latest version, 1.3.3 of Spray Framework, built on top of Scala 2.11.6 and Akka 2.3.9. In this video, we have seen the Spray Framework in general, mentioned its philosophy and design principles, and outlined our choice of the Scala, Akka, and Spray versions we are going to use from now on. The knowledge we have gained in this video should be of great help as we move forward and start building RESTful web services with Spray. In the next video, we're going to learn about Spray Routing module and understand its role in defining RESTful web services and API endpoints. Hello again, welcome to the second video of Section 3. Spray routing. In the previous video, we looked at Spray Framework from a high-level perspective, discussing its philosophy, design principles, modular structure, and versioning. In this video, we're going to take a look at one of the key Spray modules, namely Spray routing, as an easy and powerful way of defining RESTful web services. Also, along this video, we're going to outline the functionality of our sample book catalog web APIs and define the basic endpoints for managing books in the catalog. One of the Spray's core promises is delivering high performance, which means operating at lowest level of abstractions possible. Spray does it very well, however. The more beefy your RESTful web services become, the higher chances that the implementation will get messy. Luckily, Spray has an alternative to offer in the form of routing. Strictly speaking, it is hard to find the exact definition of what term routing means, but the general idea behind it is pretty simple. Provide a way to describe and bind the handler to the given URI. Spray routing provides a flexible domain-specific language, or DSL, for expressing RESTful web service behavior in a structural, readable, and composable way. In essence, it is a higher-level abstraction over low-level pattern matching implementation against HTTP request we have seen before. Along this course, we're going to rely solely on Spray routing for developing our book catalog RESTful web services. Routes are at the heart of Spray routing. All structures which are defined using routing DSL are subtypes of type route, a simple function with a single argument, request context returning nothing. We may wonder what is special about it, but there is a very important property associated with the way how routes operate: composition. Routes could be composed in such a way that they could be chainable. Many routes could be composed or chained together. Transformable and filterable. Request, response, or both, could be filtered or changed in the process. Hierarchical. Routes could be organized in a tree structure. In Spray routing, directives play the role of building blocks, which could be used to construct arbitrary complex route structures. In general, every directive has a name, may have arguments, and may provide some extractions. Essentially, each directive may do one or more of the following things: transform the incoming request context, filter the request context according to some rules, extract values from the request context, complete the request. Similarly to the routes, directives could be composed and in addition combined together in a type-safe fashion. There are many classes of the directives, but by and large they could be split into two distinct groups. Directives which filter or extract from the request. Directives which create or transform the response. I'm sure at this point we are really excited about spray routes, directives, and the way how they play nicely together. Before we switch over to the coding of the book's catalog web service routes, we need to cover the last piece of the puzzle. Where should we define our routes? Where do they live? Spray routing makes all relevant parts of the routing DSL available through the HTTP Service Actor abstract class, which itself is an Akka actor. Apart from all the predefined directives inherited from HTTP Service Trait, HTTP Service Actor provides one more important thing: the run route wrapper. This function bridges together routes structure and the enclosing Akka actors receive partial function. Data model. Before going into API details, it is good to understand the data model of our sample book catalog application. To keep things simple, we're going to have two core entities, publisher and book, linked together by one-to-many relationship. One publisher may have published many books. Every book has an ISBN property. We are going to rely on the ISBN 13 standard. Title and author. In this respect, our model is overly simplified, as every book may have many authors, and every author may write many books. But even this simple model needs quite a number of different APIs, as we're going to see shortly. API outline. Following the traditional convention of RESTful architecture style, we're going to support two types of resources, books and publishers. We are going to support the basic HTTP methods get, post, put, and delete, in order to provide a complete set of features to manipulate the books and the publishers. Although web services and APIs versioning is not in the scope of our video course, it is always good to think ahead and plan for API evolution. This would be the first version of our book catalog, and we're going to record this fact inside URI path. Routes. Now, when data model, resources, and API are all set, we are ready to express it using spray routing DSL. In most cases, it is a very straightforward process. As we can see, everything we discussed so far with respect to routes and directives is there. Path matching, extractions, routes chaining, and composition. Thanks to spray routing, the book catalog web API's definition looks very clear and concise. HTTP Service Actor. At the very end, what we need to do is to create Book REST Service Actor, which extends HTTP Service Actor and injects the routes we have defined before into run route wrapper. And that's it. In this video, we have learned about spray routing module as, by all means, a preferable way for defining and managing RESTful web services using Spray framework. In the next video, we're going to continue our discussion about spray routing module, this time putting emphasis on marshalling, unmarshalling support using JSON format and failure handling. Hi, and welcome to the third video of the third section. In the previous video, we discussed Spray routing module and the power it brings for defining RESTful web services in Spray framework using routes. In this video, we're going to continue our acquaintance with Spray routing module capabilities by discussing marshalling support and handling failure conditions. In the previous video, we have finished up by creating the fully fledged book catalog RESTful web services skeleton. But there are a couple of the topics we have not yet touched on. One of those is data contracts between servers and clients, and it is time for us to take a look at how to manipulate data representation, also known as marshalling, which essentially concludes the route processing by delivering response to the client. REST architecture style does not mandate a particular representation format, but the modern web is dominated by JSON or JavaScript object notation. Luckily, Spray's support of JSON protocol is excellent, and available as a spray-json module. It is really easy to use, and in most cases, it involves a call to one of the predefined JSON format functions. JSON formats. As we are going to exchange books and publishers' details using JSON representation, we're going to introduce implicit formatting functions into the scope and use spray-json predefined format methods to do the work. Interestingly, spray-json does not support JODA time and its local date type, so we have to take care of that ourselves and define our own local date JSON protocol. Great example of how easy it is to support our own data types and data structures. Seamless integration between Spray routing, spray-json, and Spray HTTPX modules makes it possible to implicitly marshal class instances into JSON representation by just returning them as the response completion result. Not only that, same integration and convenience Spray routing directives allow to unmarshal the request payload, in our example JSON body, into instances of respective classes. Not everything is following the happy path scenario, and the reality is that different failures and erroneous conditions are going to happen, no doubt. Essentially, Spray routing distinguishes two major classes of errors, exceptions and timeouts. The way to handle those classes of errors is somewhat different. In case of exception handling, there should be an implicit partial function of type exception handler provided, or alternatively, handle exceptions directive could be used. With respect to timeouts, there should be override provided for timeout root definition of the HTTP service actor class. For both exceptions and timeouts, handling Spray provides default implementations. In this video, we have finished learning about Spray routing modules as, by all means, a preferable way for defining and managing RESTful web services using Spray framework. We have outlined our sample book catalog web API by defining the appropriate routes. However, there is one step missed. We need an HTTP server instance. In the next video, we're going to take a look at another key Spray module, spray-can. We will take all the routes that we have defined up to this moment as part of Book Catalog RESTful Web Service and attach them to the running HTTP server so they become alive and accessible to the outside world. Hi, in the previous video we looked at Spray routing DSL as the concise and readable way of defining our own RESTful Web Services API. In this video, we're going to take one more step forward towards exposing our RESTful Web Services to the outside world by looking at spray-can and core HTTP support implementation in Spray framework. At the end of this video, we're going to have our sample book catalog web services up and running, ready to serve HTTP request. Spray framework has excellent HTTP 1.1 support, both from server-side and client-side. Along this video, we are going to focus on spray-can HTTP server only. However, we will get back to the client side later in the course. The spray-can HTTP server implementation is scoped with a clear focus on the essential functionality of an HTTP 1.1 server: connection management, message parsing and header separation, timeout management, response ordering. Everything else is left aside and becomes the responsibility of other modules. Akka framework and actor-based architecture are the core recipes of spray-can ability to support many thousands of concurrent connections and deliver a high throughput. Secure HTTP communication based on SSL and TLS protocols is an essential feature these days, and spray-can fully supports that. Although our book catalog RESTful web services are not explicitly using advanced HTTP protocol features like persistent connections, streaming, and pipelining, spray-can supports that as well. As we already know, spray-can HTTP server is built on top of Akka framework and actors. In terms of a implementation, spray-can HTTP server could be stated by sending an http.bind command to the HTTP extension hosted by Akka IO layer. The HTTP bind command registers an application-level listener actor, for example, our book REST service actor instance, and specifies the interface and port to bind to. It is important to mention that there is a couple of additional settings and options which HTTP bind command carries over, and we are going to see that later in the course. Essentially, that's it. Once the HTTP bind is processed, we have a full-blown Spray HTTP server up and running, ready to serve the request. Now, let's switch back to the code and apply what we just learned to bootstrap the instance of book REST service. For that reason, we're going to create a basic Scala application with the initialization code block right inside it. There are a few ways to gracefully shut down running spray-can HTTP server. The simplest one is by sending http.closeAll command to the HTTP extension and shutting down the actor system upon acknowledgement. Another one, a bit more complicated, but with more fine-grained control, is to send http.unbind to HTTP listener instance. Spray Framework supports a wide range of configuration parameters. Most of them have reasonable sensitive defaults applicable to many applications, but there is always an option to override them inside application.conf configuration file. Mostly, every module has its own configuration subsection, and although we have not touched Spray routing configuration, we are going to tailor spray-can properties a bit. In particular, we will override two properties: idle timeout, the time after which an idle connection will be automatically closed; request timeout, the time to wait for request to be responded before timing out. The full list of spray-can configuration properties is really impressive and is available on Spray's official website. Some of those properties are going to pop up later on, right in the next section, where we'll configure our spray-can HTTP server to support HTTPS protocol. In this video, we have closed the loop and looked at the embedded HTTP server implementation provided by spray-can to host our own RESTful web services and APIs. In the section 8, the last section of this video course, we are going to get back to spray-can and get familiarized with HTTP client-side implementation it provides. In the next video, we will take a look at a couple of simple ways to consume RESTful web services and APIs using different web browsers and command line tools. Hi again. In the previous video, we looked at the spray-can module, and finally got our sample book catalog RESTful web services up and running. In this video, we're going to take a look at how we can invoke our sample book catalog web APIs using command line tools, browsers, and browser plugins. This is an exciting milestone for our journey into Scala web development using Spray Framework, because we're going to see what we have built so far in action. We used to use browsers to surf the always expanding universe of the websites and portals. However, browsers can also be used to access RESTful web services and APIs which support HTTP GET requests. For example, let us navigate to our book application catalog web API, which returns the list of the books. The result does not look pretty, as by default, every browser visualizes JSON data differently, but still, we can see and read it there. Browsers are capable of doing much more, and this power is available to end users through rich ecosystem of the plugins and add-ons. Postman is probably the best known example of the plugin to access RESTful web services and API. Available for Google Chrome browser, its features are endless, and if you are a Chrome user, your search is over. This is what you need. REST Client is a popular browser add-on for Firefox. It has fewer features than Postman, however, in many cases it is good enough. The truth is, the list of browser plugins and add-ons to access RESTful web services and APIs is long enough. In most cases, it depends on the browser of your choice, and really, most of us just use one. For Google Chrome users, Postman is the obvious choice. For Firefox, probably REST Client is good enough. Apple Safari, Opera, Microsoft Internet Explorer have their own plugin ecosystem. For more experienced, or better to say old-school users and developers, Command Line is the best choice to play with RESTful web services and API. There are plenty of options here, but we're going to take a look at two of the most popular ones, curl and HTTP. Curl is the oldest command line tool to dial with HTTP-based services and APIs. It is available in most Linux distributions and has tons of the command line options. In its simple form, we can just point it to some URL, for example, curl http://localhost:9001/API/v1/books. For more verbose output, we can pass -iv options and have access to the HTTP headers as well. For example, curl -iv http://localhost:9001/API/v1/books. HTTP is a user-friendly curl replacement feature intuitive UI, JSON support, syntax highlighting, extensions, and many more features. Although it requires some prerequisites to be installed, this tool is too much more pleasant to work with. Both curl and HTTP are going to be our best friends along the next sections of the course, helping us to quickly explore and verify the features we are going to pipe into book catalog web services. In this video, we have learned a couple of different ways to access RESTful web services and APIs using web browsers and command line tools. It concludes the section where we firstly learned about terrific Spray framework and then developed the first prototype of our book catalog web APIs. I hope at this moment every one of us can say, I love Spray. And our love is going to get stronger and stronger. Along the next sections, we're going to build a lot of things on top of book catalog application, adding more features and functionality to it. In the next section, we're going to talk about security and the ways to protect our book catalog web APIs on multiple levels, including the transport one. In the previous section, we dug into Spray framework and started to build our book catalog application. In this section, we will talk about security in the context of RESTful web services and APIs. Security in general constitutes of many processes and procedures. However, arguably, the most important ones are authentication and authorization. More to that. Whenever implementation of security workflows involves a network communication with external systems, like in case of RESTful web services and APIs, secure transport layer becomes a critical piece of the puzzle. In this section, we're going to discuss what is authentication and authorization, and finish up by looking at secure version of HTTP protocol, HTTPS. Now we are moving on to the first video of this section, that is going to serve as an introduction to the authentication basics and its support in Spray framework. In this video, we're going to take a look at the core meaning of authentication and what kind of support Spray framework provides for it. In particular, we're going to discuss what Spray routing DSL can offer with respect to enriching routes with authentication support. Generally speaking, a user can be given access to secure systems based on his or her credentials that imply authenticity. As such, to put it simply, authentication is a process to confirm a user's identity by verifying the supplied credentials against some trusted services or data stores. There are many authentication methods available at the moment. However, the simplest and still widely used one is password-based authentication, when user provides its username and password. HTTP protocol specification supports basic authentication scheme based on usage of the predefined request and response headers. Spray framework supports HTTP basic authentication through the Basic HTTP Authenticator and Basic Auth classes. It is very important to understand that HTTP basic authentication does not provide any confidentiality protection, namely encryption or hashing, for the transmitted credentials. Because of this weakness, it is strongly recommended to use secure HTTP, HTTPS, in conjunction with HTTP basic authentication. Out of the box, Spray provides the way to specify username-password pairs in the subsection of the configuration file application.conf, or to use integration with LDAP server. Both options are based on User Pass Authenticator. Spray routing has excellent support for HTTP basic authentication by providing a dedicated authenticate directive. It accepts the authenticator and returns the authenticated principal, usually user, in cases of success, or reject the request if credentials are not invalid. Now, let's see how we can integrate HTTP basic authentication into our book catalog web services. We will neither be using application.conf or LDAP to manage the users of our book catalog. Instead, we will store users in the internal data storage, for example, in-memory database, and implement our own user path authenticator to support that. Let us start from the simple user model, which includes only username and password properties. The salt property requires a bit of explanation here. First and foremost rule of any software system which manages users is never store passwords in clear text. Instead, use string hashing algorithm with some entropy like salt, which ensures that the same password will never have the same hash. The Open Web Application Security Project, or OWASP, is a great source for best practices which touches a wide range of security topics related to web applications, services and APIs. All that is available at OWASP official website. As we remember, essentially, User Pass Authenticator is just a function, which in our case should accept username password and returns the instance of user object. It is going to be done by authenticate method in the user service class. With User Pass Authenticator implementation available, we are ready to protect our book catalog web services by requiring authentication for some of the routes, which lead to modification of the catalog. Also to be noted, Spray routing has another directive called Optional Authenticate, which may or may not return authenticated principal, depending if credentials were supplied or not. In this video, we have started to learn the ways to secure our RESTful web services and APIs using the mechanisms provided by Spray Framework. We understood what authentication is and how it works in the world of HTTP servers and clients. In the next video, we're going to dig deeper into security topics by discussing the authorization mechanism and fine-grained access control to resources. In the previous video, we learned what authentication is in the context of web services and APIs. In this video, we're going to tackle another important security measure called authorization. We will be taking a look at authorization as another mechanism to limit the access to protected resources, and what Spray routing DSL can offer with respect to its support. When the computer system or web service knows who's accessing it, it can take one step forward and restrict or allow the requester to perform a particular action. Most intuitive example is associating roles with each user of the system, letting administrators to have more freedom than regular users. Getting back to book catalog web services, it sounds like a good idea to let only power users to modify, delete, create, or update books and publishers from the catalog. Let us think what we can do about that. There are many different approaches to the model access control. ranging from the native to quite complex. For the book catalog, we're going to assign every user a set of permissions to manage publishers and books. Spray routing provides a dedicated authoritative directive which just accepts the Boolean value, or the function which returns Boolean value. If the eventual value passed to authorized directive is resolved to false, the request is going to be forbidden. Now, when we know how authentication and authorization is supported by spray routing, we came to a point to apply this knowledge in practice by protecting some of our book catalog web APIs. Let us see what happens if we try to delete a book as a user which does not have enough permissions granted to perform this action. With no surprise, we are getting HTTP status code 403, which means that action is forbidden. Authentication and authorization are almost always used side by side. Luckily, HTTP protocol specification has been developed to support those concepts from day one. For example, HTTP Basic Authentication, which we have discussed in the previous video of this section, and has a dedicated headers to carry over the credentials and status codes to report failed authentication attempt 401 or failed authorization checks 403. In this video, we have talked about authorization process. Together with authentication, it provides a solid ground to build web services and APIs. However, stolen or intercepted credentials pose major security risks, which should be better avoided. In the next video, we're going to talk about Transport Level Security, TLS, and Secure HTTP Protocol, HTTPS, as additional measures to protect web services and APIs which rely on HTTP basic authentication. In the previous video, we looked at authorization process and how it complements authentication. However, we finished up at the important point that HTTP basic authentication credentials could be intercepted and whole system could be easily compromised. In this video, we're going to take a look at secure version of HTTP protocol, namely HTTPS, how it works, and how to configure spray-can HTTP server to support it. At the end of this video, we're going to have our book application web services accessible over HTTPS protocol only. The primary goal of the TLS protocol is to provide privacy and data integrity between two communicating parties, like, for example, web server and web client. At the moment, there are several versions of the TLS protocol in the wild. The latest one, TLS version 1.2, is the most secure one and is a preferred option for today's communications. The next version, 1.3 of TLS, is in working draft stage right now. Public key cryptography and digital certificates play the key role in TLS. When it comes to HTTP-based communications, we are entering the kingdom of HTTPS. Under the hood, it uses the HTTP protocol within a connection encrypted by TLS. That is why HTTPS is often referenced as HTTP over TLS. SSL, or Secure Sockets Layer Protocol, is a predecessor of TLS. It's still widely used. However, these days it is proven to be insecure and is not recommended for use. To enhance our book catalog with HTTPS support, we have to go through a couple of different stages. First of all, we have to obtain a digital certificate from the trusted certificate authorities. Usually, there is a fee to pay for that, so for development purposes, we are going to use so-called self-signed X.509 certificates. Let us go ahead and generate one using OpenSSL tool. The most important property here is the host name. More precisely, fully qualified domain name, or shortly FQDN, which we set to localhost. Once we have our certificate, we need to import it into Java Keystone, or JKS. The first step in the process is to export our X.509 certificate in PKCS #12 format. And then we're going to use KeyTool from Java's JDK distribution to create a Java key store. When command finishes, we are done, and our spray book catelog.jks keystone is there. Now, the prerequisites are done, and we are going back to book catalog application to reconfigure spray-can HTTP server to support HTTPS. To do that, we have to create an implicit SSL context and server SSL engine provider. We also need to tell spray-can HTTP server to rely on SSL encryption. The easiest way to do that is by using application.conf file. And lastly, we have to include SSL support trait into book catalog application class by extending it. With that, HTTPS support is all set. Let us verify that, from now on, our book catalog web APIs support HTTPS protocol only by accessing it from command line using HTTP client. In this section, we have touched upon security subjects with respect to RESTful web services and APIs. Although there was much more things to say about security, we have now a clear understanding that there are many different approaches at every layer of the system. Some of them are part of the application context itself, but others are part of global infrastructure. We have better to use all available options, as privacy of our users and confidentiality of their data must be a #1 priority. In the next section, we're going to discuss a very important subject of documenting RESTful web services and APIs. There are strong signals that our book catalog web APIs are going to be used by many independent developers and companies, so we have to make sure we provide all the necessary details to them about how to properly use the API. Welcome to section 5. In the previous section, we have discussed about security, a very important aspect of any RESTful web services or API. In this section, we're going to learn about an equally important topic of how to provide the documentation for your RESTful web services and APIs. In this section, we will start off by looking at the standard methods and best practices for documenting RESTful web services and APIs. As we will see, there are quite a lot of options out there, but we are going to fix our choice upon Swagger. In the rest of the section, we are going to discuss different Swagger specifications, the ways to integrate Swagger with the framework or library of your choice, and the terrific Swagger UI project. Now we are moving on to the first video of this section, where we are going to have an introduction into the Swagger project and different techniques to document web services and APIs. In this video, we're going to take a look at some most widely used specifications and tools that are helpful for generating web API documentation. In particular, we will talk about what is Swagger Project and how it is useful for documenting web services and APIs. Over the years, industry came up with different solutions to manage and document RESTful web services and APIs. Among the leaders are Mashery, Interactive API Documentation System, API Blueprint, a powerful high-level API description language for web APIs, RAML, RESTful API Modeling Language, WADL, Web Application Description Language, Apigee, API Management Platform, Swagger, a simple yet powerful representation of your RESTful API. Although they are driven by the same goal, the approaches each of these solutions is taking are quite different. Some are quite formal, others are developer-oriented. Most of them are open-sourced, but there are commercial offerings as well. Swagger is one of the most popular options at the moment due to its specification comprehensives, integrations available for mostly any web framework out there. very rich ecosystem of tools, including terrific Swagger UI playground and client generators. Last but not least, it is exceptionally developer-friendly and open-sourced. As such, we are going to pick Swagger to generate the specification and document our book catalog web APIs. Let us take a closer look on what actually Swagger is. The goal of Swagger is to define a standard language-agnostic interface to the RESTful web services and APIs. The presence of such an interface is going to provide the way to discover the capabilities of any API or web service, without the need to have access to the source code. To put it simply, Swagger is a couple of things: formal specification, and large ecosystem of tools and integrations to deal with this specification. The Swagger specification defines a set of rules required to describe RESTful web services and APIs. Since 2011, it went through 4 major revisions, and currently Swagger Specification 2.0 is the most up-to-date one, although not everyone has migrated to it, and version 1.2 is still very much actively used. It is worth to note that starting January 1st, 2016, the Swagger specification has been donated to the Open API Initiative, OAI, and has been renamed to the Open API Specification. Compared with other projects and specifications, Swagger's ecosystem is the richest one, and the community is probably the largest one. The core Swagger integrations support most of the mainstream web frameworks on JVM platform. However, the community-driven integrations are available for a myriad of other frameworks written in many programming languages. And by combining those integrations with terrific Swagger tooling, the one example of such a tool, Swagger UI, we are going to discuss very soon, the benefits of using Swagger become apparent. In this video, we have briefly looked at the state-of-the-art approaches available at the moment to document RESTful web services and API. Although there is no clear winner, we are going to move on with Swagger, as it is quite popular, easy to integrate, and being actively developed project with vibrant community. In the next video, we're going to use Swagger integration with Spray framework to document our book catalog web services and APIs. In the previous video, we briefly discussed the problems and challenges of the documenting RESTful web services and APIs. Among a couple of alternatives, we decided to pick Swagger and use it to document our book application web services. In this video, we're going to take a look at how Swagger integrates with Spray applications. Also, we are going to learn different types of Swagger annotations, how documentation is generated, and how it is exposed to the outside world. As part of the video, we will document all book catalog web services and APIs so that the external vendors and developers will be able to integrate with us. Spray Swagger is a community-driven integration of the Swagger project with Spray framework. It is quite a thin layer built on top of Spray routing and essentially is encapsulated in the trait Swagger HTTP service. Under the hood, it uses a few other classes in order to retrospect and assemble web API documentation. As a matter of fact, we are going to deal with Swagger HTTP service only. Because Swagger HTTP service is a trait, it cannot be used right away, but should be inherited instead. There are a few properties to be provided, like Web API types to scan, Web API version, base URL, the desired path for documentation endpoints, and finally, API metadata in the form of API info class. Once API docs trait is defined, we are going to include it as part of Book Catalog Web Services by adding the retrospective routes into Book REST Service Actor. However, at this moment, no documentation is going to be generated, as we have not decorated our web services with required metadata yet. Swagger uses annotations to associate additional metadata with Spray routes. At API, annotation describes a top-level web API. At API operation annotation describes an operation, typically an HTTP method, against a specific URI path. @API implicit param annotation describes a single input parameter for the operation, while @API implicit params is just a wrapper for multiple @API implicit param annotations. @API model and @API model property annotations describe a generic model class, or just a bean, which is used in the web APIs, either as an input or output of the operation. @API response annotation describes a type of response which operation returns, while @API responses is just a wrapper for multiple @API response annotations. And finally, @API param describes input parameter of the operation. This annotation is not supported by spray-json at the moment. This metadata serves as a primary source of the web services and APIs documentation. Let us see how the Swagger annotations could be applied to spray routes by decorating one of the put routes of the book catalog web API, which basically performs book update. It is true that often Swagger annotations may look quite verbose and like a boilerplate, compared to method implementation, for example. However, this additional overhead is worth having a well-documented API. Last thing we have to do is to annotate our book REST service routes with @API annotation to mark is a web API. All Swagger annotations are in place and are looking good, but how can we turn them into something that could be considered documentation for our book catalog web services? Let us get introduced to resource and API listings, the Swagger way of exposing web APIs documentation through RESTful web API as well. Basically, resource listing is a high-level web API metadata, usually exposed through API docs endpoint, although it is configurable. As part of the resource listing comes the list of available web APIs, which could be queried through API listing endpoint, usually API docs, followed by API path itself. Now, when we understand how web API documentation is exposed, it is time to try it in action by issuing a couple of HTTP requests against the resource listing endpoint. As we can see, there are two APIs listed, namely Books Management and Publishers Management, available under Books and Publishers paths respectively. It is important to mention that Spray Swagger integration supports only Swagger Specification 1.2 at the moment. This information is also available as part of the resource listing metadata. Let us query the Books Management API to see how the book update route we have annotated before looks like in terms of Swagger specification. It looks promising, but in JSON format it is not very usable as is. We probably need some tool to visualize this documentation somehow. This is exactly what we are going to discuss in the next video. In this video, we have learned how Swagger integrates with Spray applications, how Spray routes could be enriched with Swagger annotation, and how the documentation itself is exposed through RESTful web APIs. In the next video, we're going to explore Swagger UI, arguably one of the most useful tools in the Swagger project portfolio. In the previous video, we learned how Swagger integrates with Spray RESTful web services and APIs. We have also complemented all our book catalog Spray routes with Swagger annotations and learned how this documentation is exposed and could be consumed. In this video, we're going to take a look at Swagger UI, the complementary tool out of the Swagger project portfolio, which greatly simplifies the web services and APIs exploration. To put it simply, Swagger UI is the browser-compatible tool to reconstruct nice visualizations of the web services and APIs out of their Swagger specification. Swagger UI works in most desktop browsers, including Chrome, Safari, Firefox, and Internet Explorer 8 and above. Swagger UI is distributed as a collection of HTML, CSS, and JavaScript files, or assets. In general, we can download it, open index.html, and type the resource listing endpoint in there. Please note that in this case, your web service has to support cross-origin resource sharing, or CORS, which is a mechanism that allows you to control the access to restricted resources outside the resource origin. Another much reliable and better way to distribute Swagger UI is to bundle it along with your Spray application. It is as easy as adding the Swagger UI WebJar dependency to our project and exposing it as a static asset using getFromResource and getFromResource directory directives from Spray routing module. Now, let us run the application and navigate to book catalog root URL, which should be available on localhost port 9001 in the web browser of your choice. The Swagger UI showing all our book catalog web services and APIs should appear right away. Swagger UI could be named a fully fledged web API playground. Not only is it beautiful from design perspective, but it also provides the complete documentation for all and every web API endpoint. It includes supported HTTP methods, content types, both requests and responses, expected path or query parameters, expected request and response payloads, possible HTTP status codes, and much more. Not only that, we can call any web API endpoint live from Swagger UI by providing the necessary request payload and parameters and inspect the response returned. We definitely should try it out. Let us get back to the update book API endpoint and find it in Swagger UI. As we can see, we have shown the expected successful response, which is book JSON representation. Alternative response codes 401, 403, and 404, plus the mandatory request parameters, ISBN of the book to update and update payload. Let us fill those in and see what happens when we invoke this web API endpoint from Swagger UI. When we click on Try It Out button, the first thing we will be asked for is username and password. Remember, our book catalog web services are secured. So we have to type admin password to get through. In this case, the successful response is going to be returned. In this video, we have learned about existence of such an awesome tool as Swagger UI. It makes a real pleasure to explore and play with web services and APIs which are compliant with Swagger specifications. In this section, we have discussed a very important topic of documenting your RESTful web services and APIs. We have taken a look at the couple of available options and decided to fix our attention on Swagger project. We have seen how easy it is to make book catalog web APIs documentable by adding Swagger annotations and use Swagger UI to invoke book catalog web services live. In the next section, we're going to talk about extremely important test-driven development, TDD, practices, terrific Spray test kit module, and how to develop a full-fledged test suite for our book catalog web services. Welcome to section 6 of the course. In the previous section, we did a good job by learning how to document our RESTful web services and APIs. In this section, we're going to talk about tests which help to ensure that our RESTful web services and APIs do exactly what they're supposed to do. In this section, we will briefly discuss the state of art of the modern software testing. Right after that, jumping on to how to create test suites for Spray web services and APIs. At the end of this section, we are going to have a comprehensive test suite and test cases created for every web API endpoint of our book catalog application. Now, we move on to the first video of this section that introduces us to another Spray module, Spray Test Kit, which is dedicated to dramatically simplifying testing web services and APIs, particularly developed using Spray routing. In this video, we are going to take a look at modern software testing, focusing on what Spray Framework has to offer in this regard. As such, we're going to talk about Spray Test Kit, what problem it solves, and how it solves that problem by providing well-defined test structure. We also touched upon one of the best sides of Spray Test Kit module. It does not enforce own testing style, but integrates with mainstream Scala testing frameworks, nicely playing by their rules and conventions. By all means, modern software testing is a large and continuously evolving part of the software engineering process. TDD, or Test-Driven Development Methodology, promotes continuous, short testing cycles as part of the development process. Once a stranger, it is an essential part of the modern software engineering. BDD, or Behavior-Driven Development, has emerged from TDD and brings the testing methodology on a higher level, closer to non-technical people, by leveraging a simple, domain-specific language. Aside from the methodology, testing could be further classified by different levels of the system it is targeting. For example, unit tests, integration tests, API tests, UI tests, which is also known as testing pyramid. Down the line, there are a few dozens of the variable testing types out there: smoke testing, functional testing, A/B testing, performance testing, regression testing, etc. And last but not least, testing could use white box or black box approaches. It is a lot to discuss, but our focus is on testing Spray web services and APIs, so let us talk about that. I hope at this point we can consciously admit that developing RESTful web services and APIs using Spray Framework is a real pleasure and looks more like having fun. Although, not to forget, there are many moving parts under the hood: actor systems and actors, HTTP servers, SSL context, and certificates. The goal of Spray Test Kit module is to get rid of this complexity and to provide a simple and concise way to develop test suites. To accomplish this, Spray Test Kit provides very concise DSL for testing Spray routing applications in actorless environment. The typical Spray Test Kit test consists of three main parts: request against a particular URI or route, routes to match requests against, one or more assertions on the expected response. The test cases written in such a way do not require all the heavy lifting, like creating HTTP server and HTTP service actors, and are very fast to execute. Also, the concise and readable DSL makes test cases much easier to understand and maintain, encouraging test-driven development and test-first methodology. While request and route are the part of Spray Test Kit's scaffolding, assertions and general test suite structures are not. Over the years, Scala community has come up with numerous testing frameworks, with most notable ones being Scala Test and Spex2. Although each of these frameworks is biased towards a particular way of writing and structuring tests, they are both excellent choices and widely used. Spray Test Kit made a very wise decision and, instead of creating yet another general-purpose testing framework, just integrates with Scala Test or Spex2, providing all the necessary bits related to Spray Framework. In this video, we have learned the basics of Spray Test Kit module and the foundational techniques behind testing web services and APIs built on top of Spray routing. In the next video, we're going to develop a full-fledged test suite for our book catalog web application using both Scala Test and Spex2 frameworks as an example. In the previous video, we have gotten a brief introduction to Spray Test Kit module and the general approaches of developing test cases for Spray routing, web services and APIs. In this video, we're going to keep our hands dirty and develop a complete test suite for our book catalog web APIs. As we already know, Spray Test Kit provides excellent integration with the two most popular Scala testing frameworks, Scala Test and Spex2. We are not going to pitch one or another, but instead try out both frameworks and choose whatever style we like. They both are just great. With that, let's move on to the subject and dissect different test cases written using Scala Test and Spray Test Kit. Our first test case is very simple. Let's ensure that no publisher is going to be returned for empty book catalog. The GET indicates what kind of request and against which URI we would like to issue. The routes part indicates the list of routes to pass the request through and comes directly from book REST API routes. And lastly, we express our expectations in the form of status should be not found, meaning no publisher with identifier 1 exists. A few words to say about seal route. The way we implemented publisher lookup by its identifier is using reject empty response directive, which essentially is leading to lists of rejections being returned in case of no publisher exists. However, what we need is to have those rejections transformed into HTTP response, and seal route does exactly that. Let us take a look at a bit more complex test case where we are retrieving the list of publishers from the empty book catalog. We expect successful response and the response payload to contain the empty list of publishers. Let us raise the bar and verify that the authentication mechanism is triggered when we are trying to access a protected route. Without any credentials provided, we should not be authorized to make the request, as HTTP Basic Authentication is required, which is indicated by presence of www-authenticate header in the response. To finish up with Scala Test, let's take a look at last example where we are adding new publisher to the catalog. In this case, we are passing the credentials prepared by add credentials call along the request. Upon successful response, there are a few assertions to make. The response payload should contain the publisher with the name we have just provided, but ID could be arbitrarily assigned by the persistence implementation. The location header should point to the right publisher resource, and we are also asserting that. With this example, we're going to switch to Spex2 and develop another suite of test cases related to books management. Following the similar scenario, let us start off with a simple test case which verifies that no book should be returned from empty book catalog. Aside from a couple of minor changes, the test case looks mostly identical to the Scala test one. The next test case retrieves the list of books from the empty book catalog and asserts it has no books. The Spex2 version looks a bit more readable and compact, although it is subjective. Adding new book to the catalog assumes there is a publisher already present. In this test case, we are creating a new publisher first, then extract its URI from location header and use it to add new book into catalog. After that, we assert that book content has been properly added and location header is constructed the right way. At the very end, we are going to look at the last test case, which creates new publisher, adds a book, and then deletes the book. Although it looks quite compact, this test case tries to do too many things at the same time, and ideally it could be simplified by, for example, extracting some boilerplate into test background, like before method. Code coverage tools help a lot to understand how good your test suites are and point out on missing code blocks or branches. The great example of such a tool is Scoverage, the Scala code coverage, which we are going to integrate into Book Catalog project as well. Here is the example of how the coverage report may look like. In this section, we have mastered the art of unit testing of the web services and APIs developed using Spray framework. Delivering high-quality software to our users and partners always pays off, and TDD practices should be an integral part of your development process. Writing good, readable, and maintainable tests is a real art. The tests we have developed in this video have been written to be simple and easy to follow, although sometimes finding the right balance could be tricky. In the next section, we're going to talk about caching techniques from the perspective of RESTful web services and APIs. Hi, welcome to section 7 of the course. The previous section introduced to us the importance of unit testing of the web services and APIs, written using terrific Spray framework. In this section, we will talk about caching as one of the widely used approach to build high-performing web services and APIs. In this section, we're going to start off by understanding what the term caching or cache means and justify its place in software systems. From the general concepts, we will jump right into caching support by HTTP protocol, and more specifically, the caching techniques used by RESTful web services and APIs. At the very end, we're going to see what Spray framework can offer with respect to caching and integrate that into our Book Catalog web application. With that, let us move on to the first video of this section, where we are going to get introduced to caching and how it is being used. Up to this point, we have heard the term caching many times, but have not actually been explained what it means and why it is worth talking about. Moreover, the first section of the course stated that being cacheable is one of the properties of REST architecture style, so it is time to discuss this topic. In this video, we're going to address all the questions we may have related to caching. In particular, fixing our attention to its applicability to HTTP and RESTful web services. Caching has many faces and is extensively used not only by software systems but hardware as well, being deeply integrated into modern CPU architectures. But the idea of caching is really simple. Just hold some data or results of the computation, so whenever same request comes in, it could be served immediately by sending off the data directly from cache, without refetching it or redoing the computation again. The immediate gains of effective caching are much faster request processing. However, caching brings a whole new class of different problems and challenges to address, and Phil Carlton's quote still holds truth these days. Removing or refreshing the stale cache data, also known as cache invalidation, could be a complex problem. The HTTP 1.1 protocol specification includes a number of elements intended to make it possible to improve performance by the use of response caches. The most basic one is the cache control header and time-based caching using expires, last modified, and if modified since headers. Semantic of cache control headers is a bit complex, but in the essence, it defines who can cache the response, under which conditions, and for how long. It is good to know that cache control, expires, last modified, and if modified since headers are supported by all modern browsers. That means once the browser gets the response, which could be cached, the next request to the same resource may not go to the remote server at all, and may be served immediately from the browser's internal cache store. HTTP 1.1 protocol specification defines yet another mechanism for effective caching based on entity tags, or E-tags, and conditional request headers, E-tag if match, if none match. It is also known as content-based caching. An E-tag is some kind of identifier or hash which is assigned by a server to a specific version of a resource, referenced by the URL. If the resource representation at that URL changes, a new and different E-tag is going to be generated and assigned. With this regards, E-tags are very similar to fingerprints. They uniquely identify the particular resource representation and can be quickly compared to determine whether two representations of the resource are the same. Let us take a look at how this caching mechanism works in practice. The client, let's say the one we already know about, HTTP, sends the request to get the book from the catalogue by its ISBN. Along with the response and book payload, server sends an E-tag header assigned to this particular book representation. Next time, if the client requests the same book again, it sends the if none match header with the E-tag value received from the server before. The server checks if the book's representation has been changed by generating the new E-tag and comparing it. With the one from if none matched header, if the values are identical, it means that book's representation did not change and the server returns HTTP status code 304, not modified, without including book payload. In this video, we have just scratched the surface of such an important topic as caching. We spent most of our time by discussing the different caching mechanism provided by HTTP protocol specifications and how they are typically used by browsers and independent clients. In the next video, we're going to learn about another Spray module, spray caching, and the capabilities it provides. In the previous video, we learned what is caching in general and how it is supported by HTTP protocol specification. In this video, we're going to take a look at the couple of different levels of caching support in Spray framework. We're going to begin by introducing new module, spray caching, and a few cache implementation strategies it provides. Then, we're going to slowly drift towards spray routing directives, which are dedicated to caching and E-tag support. Close to the end of the video, we will enhance our book catalog RESTful web services by integrating caching and conditional request headers processing. It is fair to say that spray caching provides one thing and one thing only, the cache abstraction, and bundles a couple of in-memory cache implementations. However, what distinguishes the Spray's approach is that instead of caching the concrete value, which most of the cache implementation do, the future is being stored in the cache. Spray caching is built around simple cache trait. Out of the box, there are two implementations provided. Simple LaRue cache, cache with limited capacity, which employs last recently used policy. The entries that have not been accessed for the longest time are evicted first. Expiring LaRue cache, basically enhanced version of simple LaRue cache, which additionally supports time to live and time to idle expiration. Under the hood, both implementations are built on top of concurrent linked hash map library, which at the moment is superseded by caffeine cache implementation. Spray caching has a set of convenient companion objects to make cache creation a breeze, essentially narrowing it down to one line of code. While spray caching provided the necessary caching abstractions and implementation, spray routing, in turn, has a dedicated set of directives, which could be split into two classes. Directives which allows to directly cache the result of the route execution, directives to support e-tags and conditional request headers. Although those classes are somewhat independent from each other, they both could benefit from the building blocks which spray caching provides, directly or indirectly. It is worth to mention that some spray routing directives do support implicit caching, for example, file and resource directives, to effectively serve the static content. Let us take a look on a quick example of how we can cache the result of the book catalog web API, which returns publisher by its identifier. Just adding one cache directive and supplying the response cache we have created before does the entire job. The first requests are going to hit the data store, but the consequent requests to the same publishers will be served from the cache immediately. Looks really simple and straightforward, but not to forget the cache needs to be invalidated in case publisher is deleted or modified. At this case, we have to remove or update the respective cache entry manually. Caching the response is great, but we still have to return the payload to the client. What if we could communicate to the client that the book it has asked for before has not been changed? E-tags and conditional request headers is what we need. Let us apply the conditional spray routing directive to book catalog web service, which retrieves a book by its ISBN number. Now, let's see what is going to happen when we issue the GET request for the book which exists in catalog. Please pay particular attention to the new e-tag response header, which server has returned to us. Moving on, let's issue the same request, but this time passing the value from e-tag response header as if none match request header. This time, server answers with a special header 304 not modified, which basically indicates that the book's representation client has, identified by its e-tag value, is up to date with the one server currently has. In this case, no book.json payload has been sent. In this video, we have looked at the Spray caching module and different caching implementations Spray framework offers at the moment. We have also enhanced our book RESTful web services with two different caching techniques and discussed the practical benefits of doing that. Hopefully, this section was able to convince us that caching is really an important building block of any scalable RESTful web services and APIs, and probably any modern, more or less complex software system. Although Spray caching and Spray routing tandem makes it very easy to integrate caching capabilities into Spray application, as we have seen by enhancing our book catalog, keeping caches in sync with the actual data becomes another challenge to address. In the next section, we're going to discuss a very important topic of the inter-web services and APIs communications. In other words, integration with external RESTful web services. Hi, and welcome to the last section of the course. In the previous section, we have talked about caching support in the Spray framework. This section is going to be a final destination of our journey into the universe of web development using Scala and Spray framework. In this section, we're going to switch our gears a bit and jump off from server-side development to client-side development. We will learn about yet another great member of Spray framework portfolio, Spray Client Module, and discuss how it is using Spray CAN HTTP client APIs. Now we are ready to move on to the first video of this section, where we are going to get introduced to the Spray Client Module and the basics of creating web service clients. In this video, we're going to take a look at some of the most popular libraries used these days, which provide client-side APIs for accessible, RESTful web services, and discuss Spray Client Module as one of the appealing alternatives, particularly for the applications built on top of Spray framework. To consolidate what we have learned about Spray Client, we are going to create a simple client for publicly accessing Google Books API to search the books. With respect to creating web service clients, there are plenty of excellent libraries developed by the community, ranging from Apache HTTP components, Jetty client, Project Grizzly client to Async HTTP client, Netty client, and OK HTTP. Many of them are built on foundations of asynchronous and non-blocking models and are excellent choices in most use cases. Spray Client is a lesser-known option and is not as widely used as others. However, it is a natural choice for the applications built on top of Spray Framework. Spray Client is probably one of the smallest Spray modules with respect to exposed API and implementation. It is mostly solely built on top of other module, Spray Can, and its HTTP client API. Spray Client is built around single send-receive abstraction, or better to say, pipeline, which is just a function from HTTP request to future of the HTTP response. In Section 3 of this course, we have learned about Spray Can module and its server-side API in a form of high-performing HTTP server. However, we have mentioned that it also provides client-side API, and now it is a time to talk about that. Depending on the Spray Can client API chosen, the different ways of getting send-receive function instance are available. Connection level API is the lowest level one, and at the moment there are no convenient ways of using it with Spray Client. Host level API takes off a lot of boilerplate out of connection level API and provides high-level abstractions to communicate with particular host or server. Spray Client could be used with host level API, but still, it requires a lot of coding to be done. Lastly, on the highest level of HTTP client API abstractions sit request level API. Spray Can client has a really simple and concise integration with it. It truly shines when used in context of Spray routings, HTTP service, trait, as we are going to see very soon. By all means, this is the simplest way to use Spray Client in the Spray applications. As most of the key Spray modules, Spray Client has own set of configuration properties available under Spray Client section inside already familiar application.conf file. Spray Client provides many convenient methods to properly construct arbitrary complex request-response pipelines. Using the already constructed pipeline is as easy as just feeding it the appropriate HTTP request, which could be built using one of the request builders like GET and POST, as well as put, patch, delete, options, and head. It would be nice to have some kind of search functionality available in our book catalog web services. However, as of now, there are not as many books in the catalog as we would like to have, so finding some service to fill this gap would be awesome. Google Books API looks like exactly what we are looking for. Moreover, the Search API endpoint is free and publicly available. Google Books Search API consists of a single endpoint, which accepts a search terms to look for in the query parameter, although some special keywords are also supported. The response is returned in JSON format and has a huge list of different properties. For the purpose of this example, we are going to extract only a few of them. Basically, all we have to do is to build the pipeline using appropriate version send-receive and adding additional response transformers. Then, we just call this pipeline using the respective HTTP method and URI. In this video, we have learned about Spray Client module and the different ways of integrating with external RESTful web services and APIs. In the next video, we're going to talk about general approaches of testing, the Spray client-based integrations which invoke external RESTful web services. Hi, and welcome to the last video of this course. In the previous video, we looked at Spray Client module and developed our own integration with Google Books Search API. In this video, we're going to take a closer look at the implementation we have developed so far. Try it out and come up with a set of test cases to ensure that our integration with Google Books Search API works as expected. Also, we are going to discuss some common techniques in order to avoid calling external web services during the test case executions, nonetheless ensuring that the code we have written is well tested. In the previous video, we have seen some snippets of our client for Google Books Search API. But essentially, the complete version does look exactly the same. Simple and readable, thanks to Spray Client pipelining. In our book catalog web services, this search functionality is exposed under Search Endpoint and essentially just delegates the call to Google Books Search API client. In cases when Google Books Search returns unsuccessful response, our Book Search API catches that and hides this fact behind empty response. It is always a good idea to handle possible errors during the communication with external web services, as they are surely going to happen. Let us make sure our Book Catalog Search API returns the expected responses by looking for the books matching Scala programming query. We have gotten back quite a lot of the results, which is a good sign that integration with Google Books Search API is working just fine. Getting back to what we have learned in Section 6 about developing unit tests for Spray Web Services and API, let us introduce a simple test case for our Book Catalog Search API endpoint. If we run it like that right now, it's going to fail for a simple reason. We expect no results returned, but instead, the Google Books Search API has been called during test execution, and real results have been returned. Although it might sound right, how else can we ensure everything works? Calling real external systems during unit test runs is considered a bad practice for at least the following reasons. It can cause side effects, as real system is being called. It can cause instability due to nature of the network communication. It can flood external systems with the requests, making them unavailable. There are a couple of techniques proven to be useful in the unit testing to deal with this kind of issues. Mocks are often used by testing practitioners to isolate the external dependencies by simulating their presence or mocking. Let us take a quick look at example of the mocking technique by creating a mock of Spray Client pipeline. Instead of calling the Google Books Search API, we simulate the successful response by returning some hard-coded payload, depending on the query string. With this mock in place, our test cases which were failing below are turning green now. For the sake of experiment, let us add another useful test case which verifies that some results are returned by the search web service, following the rules of our mock. Another, slightly different technique which often appears in testing is stubbing. Instead of simulating the dependency, the stub, or so-called dummy implementation, is going to be used instead. For us, it means having a dummy Google Books Search API endpoint available somewhere. What could suit better for creating RESTful web services stubs than Spray Framework? We already know all the necessary building blocks and are able to easily create a Spray-based web service to mimic Google Books Search API. In the simplest use case, we could also have a predefined response, but leaving this choice to test case to decide is a better option. Comparing to mocks, we had a little bit more code to prepare test background. However, stubbing opens much more opportunities for developing various kinds of tests as close to real-world scenarios as possible. It is rare these days that web services and APIs do not need to communicate with external systems. They often could be thought of as a framework of independent components, calling each other rather than standalone pieces. In this section, we have learned about Spray Client module and got the basic understanding of what it means to be a client of external RESTful web services and APIs. This last section puts a period to entire course, but it is just a starting point of your own exciting journeys. We have covered a lot of different topics, ranging from RESTful architecture and concurrency modules to Spray framework, testing techniques and RESTful APIs documentation. The solid foundation has been built, and it is time to make use of it in real world by building beautiful RESTful web services and APIs using Scala, Akka, and Spray. With that, our Learning Scala web development course is coming to the end. Hopefully, you have enjoyed it, and Spray Framework is going to reserve a valuable place in your development toolbox. Please do not hesitate to contact me over LinkedIn, GitHub, or personal blog at Blogspot. It would be my pleasure to address any questions or concerns you may have related to the course, and not only that. Good luck and bonne chance!